You've sent out 50 resumes. 100. You've customized every single cover letter. You've polished your GitHub profile until it shines. You spend hours on LeetCode, grinding out problems until you dream in binary search. You finally land an interview for a dream tech job in the States. A six-figure opportunity that could change your life. You nail the technical questions. You talk about your projects with passion. You walk out feeling confident, maybe even excited. And then nothing. Absolute radio silence. A few weeks later, you get that soul-crushing automated email. Thank you for your interest, but we've decided to move forward with other candidates. If this sounds even remotely familiar, you need to stop what you're doing and listen. Because you are likely making the single most common and most fatal mistake that 90% of tech job applicants make. And the crazy part is, it has almost nothing to do with how well you can code. I want to tell you a quick story. A few years ago, I was sitting in on a final round of interviews for a senior software engineer position at a major tech company. The salary was well over $175,000 plus stock. The first candidate, let's call him Alex, was perfect on paper. He had a computer science degree from a top-tier university, a resume packed with impressive internships, and he flew through the initial coding challenges like they were nothing. He was polished, he was smart, and he was the team's favorite going in. Then came the final big-picture design question. The interviewer said, "Okay, Alex, let's say we need to design a simple URL shortening service, something like Bitly. How would you approach it?" Alex dove right in. He started talking about database schemas, hash functions, and API endpoints. He was technically brilliant. But after about 10 minutes, the energy in the room just died. The interviewers were nodding, but their eyes were glazed over. The next candidate was Sarah. Sarah didn't have a fancy degree. She was self-taught, a graduate of an online boot camp. Her resume was good, but not nearly as impressive as Alex's. When she got the same question, design a URL shortening service, she did something completely different. She paused. She took a breath. And then she started asking questions. Okay, before I write a single line of code, let's clarify. What's the scale we're talking about? Are we expecting 1,000 clicks a day or a billion? What's our primary goal? Is it speed? Is it 100% availability? What kind of analytics do our users need? How are we going to handle custom URLs? What's the plan for when a link goes viral and gets hit with 1 million requests in 1 minute? For the next 20 minutes, she didn't talk about code. She talked about the system. She talked about trade-offs, failure points, and user experience. She was building a mental model of the entire problem before she ever considered the solution. Sarah got the job offer that afternoon. Alex did not. What did Sarah have that Alex didn't? It wasn't a better understanding of algorithms. It wasn't a secret programming language. It was a completely different way of thinking. This is the one skill I'm talking about in the title of this video. It's the invisible barrier standing between you and a top-tier US tech job. It's the skill that separates the code monkeys from the true engineers, the people who get paid a decent salary from the people who build game-changing careers. In this video, I am going to pull back the curtain on this exact skill. I'm going to show you precisely what it is, why companies like Google, Amazon, and Netflix are desperately searching for it, and most importantly, how you can start building it today. This isn't about grinding more LeetCode. It's not about getting another certification to slap on your LinkedIn. This is about fundamentally rewiring the way you approach problems so that when you walk into that interview room, you don't just sound like someone who can code, you sound like someone who can think. You sound like someone who can solve real, messy, complex business problems. The truth is, the American tech industry has a massive surplus of people who can write code. Boot camps and online courses are churning out junior developers by the thousands. But what the industry has a severe shortage of are people who understand the big picture. People who possess what is formally known as computational thinking. Now, don't let the academic-sounding name scare you off. This isn't some abstract theory. It's the most practical money-making skill you could possibly develop. It's the foundational concept they teach in the first semester of every elite computer science program. The very skill that the title of this video alludes to. It's the core of any good computing skills course, but it's the lesson that most people forget the second they start learning about for loops and functions. They get so lost in the trees, the syntax, the libraries, the frameworks, that they completely lose sight of the forest. Computational thinking is a four-step mental framework. It's decomposition, pattern recognition, abstraction, and algorithm design. That's it. That's the multi-million-dollar secret. But knowing the names isn't enough. You have to understand how to apply them under pressure. Let's go back to Alex and Sarah. Alex, the perfect candidate, jumped straight to algorithm design. He heard URL shortener and immediately started thinking about the hashing algorithm. He was trying to show off his technical knowledge. But Sarah started at the beginning. She started with decomposition. She took the vague, massive problem of build a URL shortener and broke it down into smaller, manageable pieces by asking questions. What about the web server? The database? The API? The analytics engine? The caching layer? She was mentally disassembling the machine to see how all the parts fit together. She was exposing the complexity. This is what interviewers at top companies are trained to look for. They don't just want to know if you can solve a puzzle. They want to see how you attack a problem you've never seen before. Can you handle ambiguity? Can you break down a mountain into a pile of rocks you can actually move? The modern tech world isn't about solving clean, prepackaged problems from a textbook. It's about building and maintaining vast, interconnected, and often chaotic systems. A feature you build for the marketing team could accidentally crash the payment processing system on Black Friday. A change to the database in North America could have unforeseen latency effects for users in Asia. Everything is connected. A coder thinks about the single feature they're assigned. An engineer, someone with computational thinking, thinks about the entire system. They see the ripple effects. They anticipate the points of failure. They understand the trade-offs. That's what Sarah demonstrated by asking about scale, 1,000 clicks versus a billion. She was showing she understood that the solution isn't one size fits all. A system for 1,000 users can be built on a single server. A system for 1 billion users needs a globally distributed network, load balancers, multiple database replicas, and a content delivery network. It's a completely different universe of problems. By asking those initial questions, she proved she understood this fundamental truth of engineering before writing a single line of code. She wasn't just regurgitating a solution she memorized. She was actively designing a solution tailored to the specific constraints of the problem. She was acting like an engineer, not a student taking a test. This is the shift you need to make. You have to stop seeing interviews as exams where you need to give the one right answer, and start seeing them as collaborative problem-solving sessions where you demonstrate your thinking process. The process is more important than the final answer. So how do you do it? How do you train your brain to think this way? Especially when you're under the immense pressure of a job interview. It starts with a simple, deliberate practice. It starts by changing the way you approach every single project, every single problem, starting right now. Let's try an exercise. Right here, right now. I'm going to give you a problem, a classic, intimidating Silicon Valley-style interview question. And I want you to notice your brain's first reaction. Notice the panic. Notice the urge to grab for complex, fancy-sounding terms. Here's the question. You're hired at a brand new streaming startup. It's a competitor to Netflix and YouTube. Your task is to design the recommendation engine. Go. What just happened in your head? For 99% of people, the brain floods with a tidal wave of buzzwords. It's a defense mechanism. We want to sound smart. So you start thinking, okay, I'd use a collaborative filtering algorithm. No, wait, a content-based filtering approach or maybe a hybrid model. I'll need to build user profiles, item vectors. We could use machine learning, maybe a deep neural network with TensorFlow to process user watch history and generate embeddings. Stop. Just stop. You haven't solved anything. You've just listed a bunch of tools from a toolbox without knowing what you're trying to build. You've shown the interviewer that you've read a lot of articles, but you haven't shown them that you can think. This is the single biggest mistake brilliant, talented people make. They mistake knowing the name of a concept for understanding the concept itself. So let's rewind. Let's throw all of that jargon into a locked box and push it off a cliff. Let's approach this from first principles. Let's ask the dumbest, most obvious question imaginable. What are we actually trying to do? Forget the fancy words. In plain English, what is a recommendation engine? Well, it's a system that recommends things. It shows a user a video they might want to watch next. Okay, progress. That's the goal. Now, the next logical question. How on earth would we know what a user might want to watch? We can't read their mind. Let's get even simpler. How do you, as a human, recommend a movie to a friend? You don't run a neural network in your head. You probably think, well, you really liked The Dark Knight and you also liked Inception, and both of those were directed by Christopher Nolan. So you'll probably like The Prestige. What did you just do? You found a pattern. You used data. The data was movies my friend liked. The pattern was same director. Let's apply that to our streaming service. What is the simplest possible pattern we could use? How about this? People who watched video A also tended to watch video B. That's it. That's our starting point. So simple it almost feels stupid. But it's not stupid. It's the solid bedrock we can build a skyscraper on. The jargon-filled answer was a house of cards built on sand. So let's run with our simple idea. To make this work, what do we need? What is the absolute minimum requirement? We need data. Specifically, we need to know which users watched which videos. Let's imagine that data. It's probably just a big list. User 1 watched video A, video C, video F. User 2 watched video A, video D, video E. User 3 watched video C, video F, video G. User 4 watched video A, video C, video F. Now let's say a brand new user, user 5, comes along and watches video A. What should we recommend to them? Look at the data. User 1 watched A, then C and F. User 2 watched A, then D and E. User 4 watched A, then C and F. A is associated with C, F, D, and E. But which one is the strongest association? C appears twice with A. F appears twice with A. D appears once. E appears once. So, the most logical recommendation is either video C or video F. Congratulations! You have just designed the core logic for a recommendation engine. No jargon. No complex algorithms. Just simple step-by-step fundamental logic. This is what an interviewer at Google, at Amazon, at Meta is dying to see. They don't want a walking encyclopedia. They can buy an encyclopedia. They want a problem solver. They want to see your mind at work. They want to see you take a huge, terrifying, ambiguous problem like design a recommendation engine and break it down into tiny, manageable, logical pieces. Now, from this simple foundation, we can start building. We can start asking more intelligent questions. An interviewer would then say, okay, that's a good start. But what are the problems with this simple model? And now you're in a position to think clearly about it. Well, what if video A is the most popular video on the entire platform? Like a Super Bowl commercial or a viral cat video. Everyone has watched it. Using our current logic, we'd be recommending the same handful of videos to every single person on the site. That's not very personal. Okay, so how do we fix that? We need to find out not just what people watch, but how similar people are to each other. Let's look at our data again. User 1 watched ACF. User 4 watched ACF. These two users are identical. They have the same taste. So if user 1 goes on to watch a new video, say video H, it's a very, very strong bet that we should recommend video H to user 4. What about user 1 ACF and user 3 CFG? They have a lot in common. They both watch C and F. They have a 66% taste overlap. They are similar users. So if user 1 watched A and user 3 hasn't seen it yet, A would be a great recommendation for user 3. What we're doing here step by step is reinventing the concept of collaborative filtering. But instead of just naming the buzzword, we've built it from the ground up. We understand why it works. We know its strengths and its weaknesses. We own the idea. This is the skill. This is the one thing that separates the top 1% of tech talent from everyone else. It's not about knowing more algorithms. It's not about being the fastest coder. It's about the ability to stare into the face of chaos and complexity and calmly, methodically, break it down into its fundamental truths. This process of deconstruction, of reasoning from first principles, is the engine of all innovation. It's how Elon Musk looked at the space industry and said, what is a rocket actually made of? Aerospace-grade aluminum alloys, titanium, copper, and carbon fiber. What is the cost of those materials on the commodity market? He found that the raw materials cost only 2% of the typical price of a rocket. The rest was bloated process and lack of innovation. So he started SpaceX to build rockets from the ground up. It's how a senior engineer at Netflix looks at a massive system outage and doesn't just start rebooting servers. They ask, what is the most fundamental thing we know to be true? We know users can't stream video. Why? Because the video files aren't being delivered. Why? Because the servers that hold the files are not responding. Why? They keep asking why until they get to the absolute root cause. This analytical mindset, this refusal to be intimidated by complexity, is the most valuable and the most transferable skill in the entire tech industry. It's more important than knowing Python or Java or C++. Languages and frameworks become obsolete. The ability to think clearly is timeless. The entire field of computer science is built on this one idea. Taking an impossibly large problem, and breaking it into a series of ridiculously small, simple, solvable steps. It's about creating order out of chaos. When you demonstrate this skill in an interview, you're not just showing them you can solve a hypothetical problem. You are showing them how you will behave on day one of the job. You're showing them that when a crisis hits, you won't panic. You'll be the one in the room who takes a deep breath and asks the simple, clarifying questions that lead to a real solution. You're showing them that you are not just a coder. You are an engineer. You are an architect. We've deconstructed the what of the problem, building a recommendation engine. We've deconstructed the how, by starting with the simplest possible logic and building upon it. But we've missed the single most important question an interviewer will ask you, the one that separates a junior developer from a senior architect. And your ability to answer it depends entirely on how you structure your data from the very first second. So you're in the final round. The technical interviews are done, you've whiteboarded some code, you've talked about your past projects. You're feeling good. The senior architect across the table, the one with the calm, unreadable expression, leans forward. They smile just a little, and then they ask it. This is a great feature. It works perfectly for 1,000 users. Now tell me, what happens when you have 10 million users? What breaks first? And right there, in that moment, your entire career trajectory can change. Because this isn't a coding question. This is a systems question. This is an architecture question. This is the question. It's the moment they separate the people who can follow instructions from the people who can lead entire engineering teams. And the answer has nothing to do with writing more code or faster code. It has everything to do with the decisions you made before you wrote a single line. Let's imagine you built a simple social network. A place for people to share pictures of their dogs. Let's call it Dogstagram. Brilliant. You've got users, they can follow each other, and they can post pictures. In your interview, you proudly explain the core feature. The user's feed. When a user opens the app, they see a chronological feed of all the pictures from all the people they follow. Simple, elegant. The interviewer nods. Okay, walk me through how that works. A user logs in. What does the server do? You explain. Well, first, the server gets the user's ID. Then it looks up who that user follows. Let's say they follow 100 other people. The server then goes to our big table of posts and pulls every single post made by those 100 people. Finally, it sorts all those posts by date, from newest to oldest, and sends the top 50 back to the user's phone. You're feeling proud. It's a logical step-by-step process. It works. You've even tested it. The interviewer keeps that same calm expression. Okay, they say. So let's put some numbers on that. Your user follows 100 people. Let's say, on average, each of those people has posted 1,000 pictures. So to build the feed, your server has to look at 100 times 1,000, 100,000 posts. Every single time someone opens the app, it has to sort all 100,000 of them just to find the newest 50. Is that right? And you feel a little bead of sweat. Yeah, I guess so. And that's for one user. What if 1,000 users open the app at the same second? Now your database is trying to sort what is that? 100 million posts all at the same time. What happens to your server? You know the answer. It's the same thing that happens to a bicycle on the freeway. It gets completely, utterly overwhelmed. It melts. The app crashes for everyone. Users get angry. Your beautiful Dogstagram becomes a smoking crater in the App Store. You see, the problem wasn't your code. The logic was sound. The problem was your data structure. Your fundamental choice for how to store and retrieve information was destined to fail. You chose a structure that was easy to write but impossible to scale. Think of it like this. Imagine your job is to be a librarian for a library with 10 million books. Someone comes to you and asks for Moby Dick. In your current system, the one you just explained in the interview, all 10 million books are just thrown into one giant pile on the floor. To find Moby Dick, you have no choice but to pick up every single book, one by one, look at the cover and say nope, not Moby Dick, and throw it aside until you finally find it. It might take you 3 years. That is fundamentally what you told the computer to do. You told it to look through a giant unsorted pile of every post from every person you follow. This is what we call an ON operation, or linear time. Big O notation is just a fancy way of saying how much longer a task will take as your data grows. In this case, the time it takes to find the post is directly proportional to the number of posts you have to look through. 10 times the posts means 10 times the work. 1,000,000 times the posts means 1,000,000 times the work. This is the silent killer of so many applications. The senior architect isn't trying to be mean. They're testing your foresight. They know that a junior developer can solve the problem for today. A senior developer solves the problem for today, and for 1,000 times more users next year without rewriting everything. They build the library correctly from day one. So what does a better library look like? Well, what if instead of a giant pile you used a card catalog? Or more accurately, what if you pre-process the information? When a new book arrives, you don't just throw it on the pile. You create an index card for it. You file that card alphabetically. Now when someone asks for Moby Dick, you don't go to the pile. You go to the card catalog, flip straight to the M section, and find the exact location of the book in seconds. You've changed the work from searching through 10 million items to searching through maybe 26 drawers and then a few dozen cards. It's a seismic shift. You've just gone from an operation that takes years to one that takes seconds, even with the same number of books. This is the fundamental secret. The skill isn't just programming. It's data structuring. It's about choosing the right tool for the job. Your simple list of posts was the giant pile of books. It's easy to create but a nightmare to search. What you needed was a card catalog. In the world of computing, that card catalog can take many forms. For our Dogstagram problem, maybe the answer is that every time someone makes a new post, we don't just save the post. We also go to a special feed list for every single one of their followers and add a pointer to that new post right at the top. Think about the difference. In the old system, the work happens when you read the feed. We have to collect and sort 100,000 posts just for you to see the latest picture. In the new system, the work happens when someone writes a post. When someone posts a picture, the server does a little extra work to update the feeds of all their followers. But then when you go to read your feed, the work is already done. The server doesn't have to search for anything. It just goes to a list that is already prepared and sorted just for you, and grabs the top 50 items. It's instantaneous. The work hasn't vanished. It has been moved. We've shifted the burden from the reader to the writer. And for a social network, this makes all the difference in the world. Why? Because people read their feeds far more often than they post new content. You might scroll through Instagram 20 times a day, but only post once a week. We've chosen to do a little bit of work once during the post to save an enormous amount of work 20 times a day during the scroll. We've optimized for the most common action. This is the kind of thinking that gets you the job. This is the leap. It's realizing that the structure of your data is more important than the speed of your code. You can have the fastest computer in the world, but if you're asking it to read the entire phone book from start to finish every time you want to look up a number, you've already lost. The person with a $10 paper phone book and an understanding of alphabetical order will beat you every single time. The interviewer knows this. They've seen dozens of candidates come in and describe the first simple but fatally flawed solution. They're waiting for you to see the bigger picture. They're waiting for you to stop thinking about a single user and start thinking about the entire system. So when they ask, what breaks first? They're not looking for an answer like, oh, the server will run out of memory, or the database connection will time out. Those are just symptoms. They're looking for the disease. The disease is the data structure. The disease is the algorithm. The disease is the assumption that what works for 10 will work for 10 million. And your ability to diagnose that disease, to see past the immediate code and into the architectural blueprint of the data itself, is the one skill they are desperate to find. It's the key that unlocks not just the senior roles, but the ability to build things that last, things that can grow from a weekend project into a global phenomenon. The interviewer leans back, that same unreadable expression on their face. They've laid the trap and you've walked right into it. But now you see it. You see the pile of books and you see the card catalog. You understand the choice you have to make. And everything hangs on your next sentence. I take a slow breath. The air in the library is thick with the smell of old paper and binding glue. It's the smell of information. Of order. My eyes move from the humming sterile computer terminal to the warm solid wood of the card catalog. One is a black box, a promise of speed. The other is a transparent system, a promise of certainty. The librarian's gaze is unwavering, a silent challenge. I know what this is. This is a test of philosophy, not just a search for a book. I look the librarian dead in the eye and say, I'll use the card catalog. Flicker. That's all it is. A tiny, almost imperceptible shift in their expression. Not quite a smile, but the hard edges of their professional mask soften for a fraction of a second. They nod once, a gesture of quiet approval. As you wish, they say, and turn back to their own work, leaving me to my decision. The trap was the illusion of efficiency. The shiny new object. The easy path. The terminal represented a prepackaged solution. You type in a query and it gives you an answer. You don't need to know how it works, you just need to trust that it does. But what if it doesn't? What if the system is flawed? What if the data is indexed incorrectly? By choosing the computer, I would have been outsourcing my thinking. I would have been a user, not a builder. A consumer, not an architect. But choosing the card catalog, that's different. It's a declaration. It says, I want to understand the system from the ground up. I want to see the logic. I want to trace the path of the data myself. I walk over to the massive wooden cabinet. It's a beautiful piece of engineering. Dozens of small, perfectly fitted drawers, each with a small brass handle and a label. And art. It's the alphabet, the most fundamental sorting algorithm we learn as children. I pull open the drawer labeled CCHA. The sound it makes is a soft, satisfying shush of wood sliding against wood. Inside, hundreds of pristine white cards are packed together. A physical manifestation of metadata. I'm looking for a book on the history of cartography. I flip through the cards, my fingers brushing against the crisp edges. Carrington, Carson, Carter. The process is methodical, tactile. I'm not just searching. I'm navigating a data structure. Each card is a node containing key information. The title, the author, a brief description, and the most important piece of data on the entire card. A string of numbers and letters. The call number. The unique address. The primary key. I find it. The Golden Atlas. A history of mapmaking. I pull the card out slightly to read the number. 912.09M47G. This isn't just a random code. It's a system. The 900s are for geography and history. 912 is specifically for atlases and maps. The rest is an internal code for the author and title. I now have the exact physical address of the information I need. I haven't just found a result. I have understood its location within the entire organizational schema of the library. I slide the drawer shut, the call number committed to memory. I walk into the stacks. The silence here is different. It's heavier. I am surrounded by millions of pages, billions of words, an ocean of information. Without a system, finding one specific book would be statistically impossible. It would be a brute force search. You'd have to check every single book on every single shelf until you stumbled upon the right one. Could take a lifetime. But I have the address. I follow the signs. 100s, 300s, 700s. I'm traversing the system. Then I find the 900s. I scan the shelves. 910, 911, 912. My eyes follow the shelf, tracing the author codes. L, M, and 47. And there it is. The Golden Atlas. A large heavy book bound in dark blue leather. I pull it from the shelf. The mission is complete. As I walk back to the main desk, book in hand, the librarian looks up. This time, there's no ambiguity in their expression. It's a look of genuine respect. Well done, they say. You found it. The card catalog is a reliable system, I reply. The librarian leans forward slightly, lowering their voice. The computer would have sent you to the wrong shelf. Its index for this section was corrupted during the last software update. It would have told you the book was in the 600s. You would have searched for hours, grown frustrated, and concluded that the book was missing. You would have failed. And there it is. The lesson. The library, this whole scenario, it's not about a library. It's a perfect metaphor for the entire tech industry. And that librarian? That was your senior engineer. Your hiring manager. The gatekeeper. That interview question they ask you, the one that seems abstract and weirdly specific? How would you design a system to handle 1 billion users? Or, how would you find a single piece of data in a petabyte of information? They're not just asking a question. They're the librarian. They're showing you two tools. The shiny, easy-to-use framework, the high-level programming language, the pre-built cloud service. That's the computer terminal. And then there's the other option. The fundamental principles. The underlying logic. The data structures and algorithms. That's the card catalog. A shocking number of people entering the tech field today only know how to use the terminal. They know how to call a function, use an API, or spin up a service. They are users of a system someone else built. And they are completely lost when that system breaks, when it's too slow, or when they need to build something new from scratch. They'll type their query into the broken terminal over and over, getting more and more frustrated, blaming the tool without ever understanding the problem. But the person who gets the job, the person who becomes a truly great engineer, is the one who understands the card catalog. They understand that at its core, all software is about two things: how you store data and how you retrieve and manipulate it. That's it. That's the whole game. The card catalog is an index. It's a hash map. It's a B-tree. It's a way of organizing information so you don't have to look at every single piece of it to find what you need. This is the concept of a data structure. The process of looking up the call number and walking through the stacks to find the book? That's an algorithm. A step-by-step procedure for accomplishing a task. Choosing the card catalog over a potentially faster but unreliable computer was a decision about trade-offs. You traded the potential for instant speed for the guarantee of correctness and predictability. In computer science, we have a name for this. It's called Big O notation. It's how we measure the efficiency and scalability of our algorithms. It's the language we use to discuss whether a task will take a microsecond, a minute, or the entire lifetime of the universe to complete as the amount of data grows. The person who understands this doesn't just write code. They design systems. They build the database that powers your bank. They create the search algorithm that lets you find a needle in the internet's haystack in 0.2 seconds. They design the recommendation engine that knows what movie you want to watch next. They are the architects, not just the bricklayers. And here's the secret the industry doesn't like to advertise. We have a massive shortage of architects. We are drowning in bricklayers who know how to use the latest JavaScript framework, but can't tell you why one database query takes 3 seconds and another, nearly identical one, takes 5 hours and crashes the entire server. This one skill, this deep, fundamental understanding of how to organize information for efficiency and scale, is the single greatest differentiator between a junior coder and a senior engineer. It is the difference between a $100,000 salary and a $500,000 salary. It is the key to unlocking the most challenging, the most rewarding, and the most lucrative jobs in the entire US tech sector. It's not about memorizing 100 different sorting algorithms. It's about understanding the philosophy behind them. It's about looking at a problem and having the intuition to see the structure of the data underneath. It's about knowing instinctively that sometimes the old, manual, methodical approach of the card catalog is infinitely more powerful than the sleek, modern black box terminal. This way of thinking, this art of structuring data and the science of manipulating it efficiently, it has a name. And it is the single most important subject you could ever learn to secure a high-paying, future-proof career in technology. It's the core of the course we've been talking about. And it all starts with understanding that everything is just a library, and you have to know how to find the book. Think about it like this. When you walk into the Library of Congress, you are not expected to have read every single book. That's insane. Nobody expects that. The mark of a true scholar isn't knowing the contents of every volume. It's knowing how to use the card catalog. It's knowing how to navigate the stacks, how to find the exact piece of information you need, at the exact moment you need it. The most brilliant researcher on earth is not the one with the best memory, but the one with the best system for finding information. In technology, this is the entire game. The entire industry is a massive, constantly expanding library. Every single day, new books are written, new sections are added, and old sections are updated. Python, JavaScript, AWS, an API for a weather app, a new graphics framework, they are all just sections in this library. And the single biggest mistake that every single aspiring tech professional makes is trying to memorize the books. They buy a 1,000-page book on Python and try to read it cover to cover, memorizing every function, every class, every little piece of syntax. They feel like they're making progress because they're consuming information. They can tell you what a list comprehension is, or the difference between a tuple and a list. But then, you give them a simple real-world problem. Something like, hey, can you write me a script that takes all the photos in this folder, finds the ones taken in the last month, and renames them based on the date and time they were created? And they freeze. They stare at a blank screen. Their mind races trying to recall page 743 of their Python book. They know all the ingredients, but they have no idea how to cook the meal. They have memorized a dictionary, but they can't write a sentence. This is the moment where 90% of people quit. They conclude, I'm just not smart enough for this. I don't have the coder brain. But it has nothing to do with intelligence. It has everything to do with strategy. They were trying to memorize the library. The professional, the person with a six-figure job, approaches this completely differently. They might not even remember the exact function to get a file's creation date off the top of their head. And they don't care. Why would they waste precious brain space on something they can look up in 5 seconds? Instead, they know how to use the card catalog. Their first step isn't to write code. Their first step is to break the problem down into a series of questions they can ask the library. Question 1. How do I get a list of all files in a folder using Python? They type that almost verbatim into Google. The first result will likely be from a site like Stack Overflow or the official Python documentation. They'll see a code snippet using something called the OS module. They don't need to know the entire OS module. They just need the one function that solves this one problem. They grab it, test it, and move on. Question 2. For each file, how do I check its creation date? Back to Google. Python get file creation timestamp. Again, they'll find another function, probably from the same OS module. They'll see an example, understand how it works, and integrate it into their script. Question 3. How do I compare that date to see if it's within the last 30 days? Google. Python check if date is within last month. They'll discover the datetime module. They'll see how to get the current date, how to create a time delta object for 30 days, and how to perform the comparison. And finally, question 4. How do I rename a file? Google. Python rename file. And once again, the answer is right there, a function probably called os.rename. In less than 15 minutes, the professional has a working script. They didn't have the answers memorized. They had a system for finding the answers. They knew how to ask the right questions. They knew how to find the book. This is the skill. This is the one single foundational skill that separates the people who make it in tech from the people who burn out and quit. It's not coding. It's problem decomposition and information retrieval. It's the ability to look at a giant, intimidating problem and break it down into tiny, searchable, solvable pieces. And it's the confidence to know that the answer to every one of those tiny pieces is already out there, waiting for you in the library. You just have to be good at finding it. This is what we teach. When you enroll in this course, you're not just learning Python or how to use a database. You're learning how to be a professional information navigator. We force you to get your hands dirty. We don't give you the answers on a silver platter. We give you a problem, a real-world project, and we guide you as you learn to ask the right questions to solve it yourself. We teach you how to read documentation. That's the official manual for any piece of technology. Most beginners are terrified of documentation. It looks dense and academic. We show you that it's your best friend, your map to the library. We teach you how to effectively use sites like Stack Overflow, not just to copy and paste code, but to understand the answers, to identify the good solutions from the bad ones, and to see how other professionals have solved similar problems. We teach you how to debug. What do you do when you get a cryptic error message? The beginner panics. The professional calmly copies the most relevant part of the error, pastes it into Google, and reads the first 3 results. 99% of the time, the solution is right there. Someone else has already had your exact problem, and a dozen smart people have already explained how to fix it. This skill is a superpower, because once you have it, you are no longer limited by what you know. You are only limited by what you can ask. And that means you can learn anything. A new web framework comes out tomorrow? No problem. You don't need to buy a book and memorize it. You just need to understand its core concepts, and then you can use the library skill to look up the specifics as you go. Your company decides to switch from AWS to Google Cloud? You don't panic. You know the underlying concepts of cloud computing are similar, and you have the skill to quickly look up how Google implements a virtual server or a storage bucket. This is why companies are desperate to hire people with this skill. They don't want a walking encyclopedia. Technology changes too fast for that to be useful. What they memorized 2 years ago is probably obsolete today. They want a problem solver. They want someone who can be dropped into a new, confusing situation and using their ability to learn on the fly, find a path forward. They want someone who knows how to find the book, read the relevant chapter, and get the job done. This is the key to a future-proof career. It's not about knowing a specific language. It's about the meta skill of learning how to learn. It's about being a master of the library, not a memorizer of its books. And when you internalize this, when you stop trying to cram every piece of information into your head and instead focus on building your system for finding information, everything changes. The fear disappears. The feeling of being overwhelmed vanishes. It's replaced by a quiet confidence. The confidence that no matter what problem you're faced with, you have the ability to figure it out. That is the true foundation of a successful career in technology. But knowing how to find the information is only the first step. Once you have the book in your hands, you have to actually build something with the knowledge inside. You have to apply it. And this is where the second biggest mistake comes into play. the trap of endless learning without ever creating. It's a phenomenon I call the cookbook collector. Imagine someone who wants to be a world-class chef. So they go out and buy every single cookbook they can find. They buy Julia Child, they buy Gordon Ramsay, they buy the massive encyclopedia of French cooking techniques. Their shelves are overflowing. They can tell you the precise temperature for searing a scallop, the 17 different ways to fold a dumpling, the entire history of the sourdough starter. They watch every episode of Chef's Table. They can critique a Michelin star meal with the vocabulary of a seasoned food critic. They know everything about food, but there's one small problem. They've never actually cooked a meal. They've never felt the heat of a pan, the sting of onion in their eyes, the panic of a sauce that's about to break. If you ask them to make you a simple scrambled egg, they'd freeze. They have a mountain of theoretical knowledge, but zero practical skill. They're a librarian of recipes, not a chef. This is the exact same trap that ensnares countless aspiring tech professionals. It's called tutorial hell, and it is the single greatest dream killer I have ever seen. You know the feeling. You finish one online course on Python and you feel good. You have a certificate, but you think, I don't feel like an expert yet. I should probably learn a framework. So you take a course on Django. Then you finish that and you think, well, a real developer needs to know the front end too. So you dive into a JavaScript course, then React, then Redux, then TypeScript, then Docker, then Kubernetes. Each course provides a temporary hit of dopamine, a feeling of progress. You're collecting certificates like they're Pokemon cards. Your brain is filled with syntax and theory. You can follow along with the instructor, typing the code exactly as they do, and at the end you have a functioning to-do list or a simple weather app. But then the course ends. The instructor says goodbye. You close the video tab, and you're left staring at a blank text editor, a blinking cursor on an empty screen, and a terrifying silence. The training wheels are off, and you realize you don't know how to ride the bike. You have no idea where to even start. The thought of building something from scratch without a guide holding your hand is paralyzing. So what do? The fear is too much. The uncertainty is overwhelming. So you retreat to what's comfortable. You find another online course. You tell yourself, I just need to learn one more thing and then I'll be ready to build something on my own. This is a lie. A comfortable, seductive lie that your brain tells you to protect you from the possibility of failure. The truth is, watching someone else code is not coding. Following a tutorial is not problem solving. It's paint by numbers. The real skill, the one skill that US tech companies are desperately paying top dollar for, isn't knowledge of a specific language or framework. They can teach you that. The skill they can't teach you is the ability to stare at that blank screen, at an ambiguous problem, and create a solution out of nothing. It's the ability to struggle, to get frustrated, to spend 3 hours hunting down a bug that was caused by a single misplaced semicolon, and to not give up. That skill is not forged in the comfort of a guided tutorial. It is forged in the fire of your own projects. You have to break the cycle of passive consumption and enter the world of active creation. And it's simpler and less scary than you think. You don't need to build the next Facebook. Your first project can and should be small, messy, and maybe even a little bit embarrassing. The goal is not to create a masterpiece. The goal is to go through the entire process from idea to deployment on your own. Let's walk through it. Forget about what will look good on a resume for a moment. Pick a problem that is personal to you, a tiny annoyance in your own life. Do you have too many streaming service subscriptions and you're not sure how much you're spending? Great. That's your project. A subscription tracker. Don't write a single line of code. Open a notebook or a text file and just write in plain English what this thing needs to do. 1. It needs to let me add a new subscription with its name, cost, and billing date. 2. It needs to show me a list of all my subscriptions. 3. It needs to show me the total cost per month. That's it. That's your minimum viable product. Now you look at that first item. Let me add a new subscription. Suddenly you have a concrete problem to solve. How do I build a form that takes user input? How do I store that input somewhere after they click submit? Now you have a reason to learn. You're not just vaguely learning HTML forms. You're on a mission. You're learning HTML forms so that you can build your subscription tracker. The learning is targeted. It has a purpose. You'll build the form. It will be ugly. It won't work at first. You'll Google how to get value from input field JavaScript. You'll read a dozen articles on Stack Overflow. You'll try 10 different things that all fail. You'll feel stupid. You'll want to quit and go watch another tutorial. Don't. This moment of frustration is the most valuable part of the entire process. This is where the learning happens. This is the gym for your problem-solving muscles. When you finally figure it out, when you type a name into your ugly little form, click a button, and see console.log spit out the exact text you typed, that feeling is 1,000 times more powerful than finishing any video course. It's a victory. Your victory. Then you move to the next problem. How do I store this data? And the cycle begins again. Do I use a simple array? Local storage? Do I need a database? You'll go down a rabbit hole, but it's a productive rabbit hole driven by a real need. You'll eventually get it working. Your list of subscriptions will appear on the screen. It's a real application. It's alive. And you made it. This process, the struggle, the research, the debugging, the small victories, this is the actual job of a software engineer. This is the one skill. It's not Python. It's not React. It's the meta skill of applied problem solving. It's the grit to transform a vague idea into a tangible working thing. When you sit in a job interview at a top US tech company, they're not going to be impressed that you watched 100 hours of video content. They will be impressed when you can say, I built a subscription tracker for myself because I had a personal problem. I ran into a major issue when I tried to implement recurring billing notifications, and here's how I solved it. You're not just telling them you know a technology, you're telling them a story of how you faced a challenge, struggled, and overcame it. You are showing them, not telling them, that you have the single most valuable skill in this entire industry. You've proven you can escape the cookbook library and actually cook the meal. Building your own projects is the bridge from being a student to being an engineer. It's the only way to truly internalize knowledge and turn it into skill. It's how you escape tutorial hell forever. But here's the crucial next step. Now that you're convinced you need to build something, you have to be strategic. Because not all projects are created equal. In fact, building the wrong kind of project can be just as bad as building nothing at all, leaving you with a portfolio that gets completely ignored by recruiters. So how do you choose a project that not only builds your skills, but also makes a hiring manager stop scrolling and say, we need to talk to this person? The secret lies in a fundamental shift in thinking. Most aspiring developers think like students. They ask, what project can I build to demonstrate that I know Python? Or what can I make to show I understand React? This is the student mindset. It leads directly to the project graveyard we just talked about. The to-do list app, the weather widget, the simple calculator. A hiring manager, scrolling through 150 applications before their second cup of coffee, has seen your to-do list app. They've seen it 1,000 times. They've seen it from bootcamp grads, from self-taught coders, from computer science students. It tells them one thing and one thing only: you followed a tutorial. Proves you can copy and paste code. It's the bare minimum. It's the equivalent of a chef putting can boil water on their resume. It's technically true, but it's not going to get you a job at a Michelin star restaurant. You need to stop thinking like a student and start thinking like a professional problem solver. That's the one skill. It's not a programming language. It's not a framework. It's the ability to see a problem in the real world and use technology as a tool to solve it. A hiring manager isn't hiring a React developer. They're hiring someone to help them build a product that solves a customer's problem and makes the company money. Your portfolio needs to prove you can do that. So, how do you find a project that does this? You don't start with the technology. You start with the problem. I call this the problem-first approach. Forget about what's trendy for a moment. Forget about React versus Vue or Python versus Node.js. Instead, look around you. Look at your own life. What is a small recurring annoyance you deal with every day? Seriously, think about it. Do you spend 10 minutes every morning checking 5 different websites for news, stocks, and weather? Maybe your project is a personalized dashboard that scrapes all that information and displays it on a single page that loads instantly. Do you have 100 downloaded PDF and image files in your downloads folder named with random strings of characters? Maybe you write a simple script that automatically renames and sorts them into folders based on the date or file type. Are you applying to dozens of jobs and losing track of which resume you sent where and when you should follow up? Build a simple web app for yourself to track your applications. These ideas might sound small. They might sound unglamorous. They aren't the next Facebook. But a recruiter will look at that job application tracker 100 times before they'll look at another to-do list. Why? Because the to-do list solves a fake, generic problem. Your job tracker solves a real, specific, and painful problem that the recruiter implicitly understands you are experiencing right now. It shows initiative. It shows creativity. It shows you don't just write code. You use code to make life better. You are a problem solver. If you can't find a problem in your own life, expand your circle. Look at your friends, your family, your local community. Does your friend who's a freelance photographer spend hours manually watermarking her photos? Maybe you can build a simple desktop app using Electron that lets her drag and drop a folder of images and watermarks them all in seconds. Does your local animal shelter struggle to manage their volunteer schedule with a messy spreadsheet? Maybe you can build them a simple, password-protected site where volunteers can sign up for shifts. Now you're not just a coder. You're a creator of value. You have a user. You have feedback. You can now add a line to your resume that says, "Developed a volunteer management system for a local nonprofit, reducing scheduling conflicts by 80% and saving the coordinator 5 hours of administrative work per week." Compare that to built a to-do list app using React. Which person are you going to hire? It's not even a competition. This is the framework you need to use for every single project you consider. I call it the 3 layers of value. Every great portfolio project has these 3 layers. The first layer is technical execution. This is the baseline. Is the code clean? Does it work? Does it follow best practices? Your to-do list app lives and dies on this one layer. Proves you can write code that functions. This is the can you boil water layer. It's necessary, but it's not sufficient. The second layer is problem solution fit. This is where you separate yourself from 90% of the applicants. Did you identify a real, tangible problem and build a thoughtful solution for it? This is where your job tracker, or the animal shelter scheduler, shines. It demonstrates that you don't just see code. You see how code connects to human needs. You have product sense. You have empathy for the user. Companies are desperate for this. They can teach you a new framework in a week. They can't easily teach you how to care about solving a user's problem. But there's one more level. The third layer is impact and communication. This is the layer that gets you the offer. It's not just about building the solution. It's about being able to articulate its value. When you get into an interview and they ask you to talk about a project, you don't just say, "I built a thing with Python and Flask." You tell a story. You say, "I was applying to a lot of jobs, and I found myself getting completely disorganized with spreadsheets. I'd forget who I'd spoken to or when I was supposed to follow up. It was a genuine source of stress. So I decided to solve my own problem. I built a simple web application using a Python backend with Flask and a simple vanilla JavaScript frontend to keep it lightweight. It allowed me to track every application, set reminders for follow-ups, and store notes from every interview. It wasn't complex, but it solved a critical problem for me. In fact, it's the tool I used to make sure I followed up on my application to this company." Do you see the power in that? You've demonstrated technical skill. You've demonstrated problem solving. And you've demonstrated your ability to communicate the why. You've shown impact. You've connected your project directly to the conversation you are having in that very moment. It's a masterclass in interview performance, baked right into your project choice. So the one skill isn't just coding. It's the entire process. Identifying a real-world pain point, architecting a technological solution, executing the build, and then, crucially, communicating the story and the value of what you've created. This is the full-stack mindset that every US tech company is desperately searching for. Whether it's for a front-end, back-end, or full-stack role, they want people who think about the big picture. Your portfolio is your chance to prove you're one of those people before you even speak a word to them. It's your opening argument. And when you choose a project that solves a real problem, you're not just building an app. You're building evidence. You're building the story you're going to tell in your interview. Now, choosing the right problem is the first most critical step. But once you have that idea, the volunteer scheduler, the photo watermarker, the job tracker, the next question is just as daunting. What technology do you use? Do you build it as a web app? A mobile app? A command line tool? And how do you choose a tech stack that not only gets the job done but also aligns with the jobs you actually want? This is the classic paralysis by analysis. You're standing in a hardware store the size of a football field, and you need to build a birdhouse. There are 1,000 types of wood, 1,000,000 different screws, and 100 brands of hammers. The sheer volume of choice is so overwhelming that you just walk out empty-handed. In the world of tech, this isn't just a metaphor. It's the daily reality for aspiring developers. And the mistake nearly everyone makes is trying to solve this problem from the wrong end. They ask, what's the best programming language? Or what's the coolest new framework? They watch a charismatic YouTuber build something amazing with a niche technology and think, that's it. That's what I'll learn. They're picking their hammer before they even know if they're building a birdhouse or a skyscraper. This is a gamble. You might spend 6 months learning a technology stack that, while technically brilliant, is only in demand at 5 companies in the entire country, and none of them are hiring junior developers. You've just spent your most valuable resource, your time, on a lottery ticket. So how do you escape this trap? You stop looking at lists of technologies and you start looking at lists of jobs. This is the secret. It's so simple, so obvious in retrospect that most people miss it entirely. You need to reverse engineer your education from the job you want. You don't pick a tech stack and then hope a job exists for it. You find the jobs that exist, see what tech stack they require, and then you learn it. You are letting the market, your future employer, tell you exactly what to study. Here is your mission, and it starts today. You're going to become a data analyst, and the data you're analyzing is the job market itself. Open up LinkedIn. Open Indeed. Open Ada if you're focused on tech-first companies. Now start searching. Don't just search for software engineer. Get specific. Search for junior software engineer, entry-level developer, software engineer in major U.S. tech hubs like San Francisco, New York, Austin, Seattle, but also in the region where you actually want to live. Your goal is not to apply for jobs yet. Your goal is to collect data. Open up 20, 30, even 50 job descriptions. And as you read them, you're not just looking at the company name or the salary range. You are a detective, hunting for clues in the requirements or qualifications section. Create a simple spreadsheet or even just a text file. Make columns: front-end, back-end, database, cloud. Now you start tallying. The first job description asks for React, Node.js, and PostgreSQL, and experience with AWS. You put a little tick mark next to each of those in your columns. The next job wants Angular, Java, Spring, and MySQL running on Azure. You add those and put tick marks. The third one, React again, and Node.js, and AWS. Another tick. Do this for an hour. Do this for a whole afternoon. And a strange thing will happen. The fog of confusion will begin to clear. The overwhelming noise of 1,000 different technologies will fade, and a clear signal will emerge. Patterns will jump off the page. You will see with your own eyes that for front-end development in the US market right now, the word React appears with staggering frequency. You'll see Vue and Angular for sure, but the sheer gravity of React is undeniable. So the question of which front-end framework should I learn is no longer a philosophical debate. The market has answered it for you. For the back-end, the signal might be a little more diverse, but you'll still see clusters. You'll see a massive cluster around JavaScript with Node.js and Express. This is especially common in startups and companies with modern, full-stack JavaScript applications. You'll see another huge cluster around Python, typically with the Django or Flask frameworks. And you'll see a very strong, very stable cluster around Java with Spring, especially in larger, older, enterprise-level companies, banks, insurance companies, Fortune 500s. You'll see C# and .NET, particularly in companies that are heavily invested in the Microsoft ecosystem. The database column will tell a similar story. You'll see PostgreSQL and MySQL, the two relational database giants, appearing over and over and over again. You'll also see NoSQL databases like MongoDB, but you'll be able to see, based on your own data, which type is more prevalent for the kinds of jobs you're looking at. And then there's the cloud. AWS, Amazon Web Services. You will see it so often it will feel like a typo. You'll see Microsoft's Azure and Google Cloud Platform (GCP) as well, but the dominance of AWS in job descriptions is something you have to see to believe. Now let's go back to that original question. Do you build it as a web app? A mobile app? A command line tool? Your data has already answered this. What did you see more of in your search for junior roles? Web developers or mobile developers? Unless you were specifically searching for mobile-only roles, your list is almost certainly dominated by jobs that involve building for the web. The web is still the undisputed king for application development, and more importantly, for hiring entry-level talent. So you look at your data. You see that for the jobs you're interested in, the most common, the most in-demand combination, the hot path, is React on the front end, Node.js on the back end, PostgreSQL for the database, all deployed on AWS. Suddenly, you're not guessing anymore. You're not gambling. You have made a data-driven decision. You now have the exact blueprint for your proof of work project. You're not just building a full-stack app. You are building a React, Node, PostgreSQL, and AWS full-stack app. You are building the exact thing that dozens, if not hundreds, of companies are explicitly asking for. Every line of code you write for your project is now direct practice for the job you want. Every feature you build is another talking point for your resume and your interviews, perfectly aligned with the needs of the market. This process, this act of researching, analyzing the market, and then choosing a set of interlocking technologies, is a skill in itself. It's a meta skill, because what you've just done is more than just pick a tech stack. You've defined a system. You've outlined how a user's click in a browser running React code will travel through the internet to a server running Node.js, which will then query a PostgreSQL database for information, and then send it all the way back. You've started to think like an architect, not just a coder. And this brings us to the absolute core of it all. Learning React is not the skill. Learning Node.js is not the skill. The real foundational skill that companies are desperate to hire for is the ability to understand how all these pieces fit together. It's the ability to see the entire system from end to end, and to build not just isolated components but a complete functioning product. It's about understanding the whole, not just the parts. And that one single, overarching skill is what separates the candidates who get ignored from the ones who get hired. That skill is systems thinking. It's a term that gets thrown around in business schools and engineering departments, but for a software developer, it is the absolute bedrock of a successful career. It is the single most important meta skill you can possibly develop. And it's the one thing that most self-taught programmers and bootcamp grads are critically, fatally lacking. So what is it? Systems thinking is the ability to step back from the individual lines of code, from the single function, from the one feature you're working on, and see the entire application, the entire ecosystem as a single interconnected entity. It's the difference between a bricklayer and an architect. The bricklayer knows how to lay a perfect row of bricks. They are skilled, they are necessary, and they do good work. But the architect understands how that wall connects to the foundation, how it supports the roof, how the plumbing and electrical will run through it, how the building will handle a hurricane, and how people will actually live and work inside it 10 years from now. In the world of tech, the bricklayer is the developer who says, "My code is done, passes the tests, my ticket is complete." They've built their component in isolation. It works perfectly on their machine. They push it and they move on. The architect is the systems thinker. They're the developer who asks a completely different set of questions. They ask, if I build my feature this way, what load does it put on the database? How will this API endpoint behave when 100,000 users hit it at the same time instead of just me? How does this change affect the mobile app team? Does this new library I'm adding create a security vulnerability? Is this design scalable? Or are we going to have to rip it out and rebuild it in 6 months when our user base doubles? They see the ripple effects. They think in terms of trade-offs, feedback loops, and second-order consequences. Let me give you a concrete example. Imagine a team building a new photo sharing feature for a social media app. A component-focused developer might be tasked with building the upload button. They'll make a beautiful button, write the code to select a file from your phone, and send it to the server. Job done. The systems thinker on that same team sees a web of interconnected problems. They're thinking, okay, when the user uploads a photo, we need to generate thumbnails in 3 different sizes. That's computationally expensive. Should we do that on the user's phone to save server costs, or on the server for consistency? If we do it on the server, should it happen synchronously, making the user wait, or asynchronously in a background job? If it's a background job, how do we notify the user when it's done? What if the job fails? How do we handle retries? Where are we storing these millions of images? An S3 bucket? What's our caching strategy to make sure photos load fast? How does this affect our content delivery network costs? What metadata do we need to store with the image, location, user ID, timestamps? How does that impact our database schema? Does adding this feature open us up to people uploading malicious files? Do you see the difference? It's a night and day distinction. One person is completing a task. The other is building a product. And US tech companies, from tiny startups to giants like Google and Amazon, are desperately searching for the second person. Why? Because component thinkers create problems. They build features that break other features. They write code that works today but collapses under the weight of its own complexity tomorrow. They create technical debt that grinds entire engineering organizations to a halt. Systems thinkers solve problems before they even happen. They are force multipliers. A single systems thinker on a team of 10 can elevate the work of the entire group, preventing catastrophic mistakes and guiding the product toward a stable, scalable future. They are the ones who get promoted. They are the ones who become tech leads, principal engineers, and distinguished architects. They are the ones who are given the most interesting, high-impact projects, because the company trusts them not just to write code but to make the right decisions. This is the chasm that separates the majority of junior candidates from the ones who get hired and thrive. Most educational paths simply don't teach this. Coding bootcamps, for all their value in getting you started, are designed to teach you how to be a bricklayer. They give you a framework, a set of tools, and they drill you on building small, isolated components. They have to. They only have a few months. Online tutorials teach you how to build a to-do list app, not how to build a distributed system that serves a million people. This is where we have to talk about the why behind this series. The skill of systems thinking isn't something you learn in a weekend workshop. It's a muscle you build over time by grappling with the fundamental principles of computer science at a deep, theoretical level. It's about understanding the why behind the what. It's about understanding why a certain database indexing strategy works, not just how to implement it. It's about understanding the physics of distributed systems, the unforgiving realities of network latency and concurrent processing, not just how to call a microservice. And that is precisely what a rigorous graduate-level computer science education is designed to do. It's the entire point. A program like the Georgia Tech Online Master of Science in Computer Science, the OMSCS, is purpose-built to transform you from a coder into an architect. It's not about learning the hot new JavaScript framework of the week. It's about building a timeless foundational understanding of the systems that underpin all of modern technology. When you take a course like Advanced Operating Systems, you're not just learning commands. You are diving into the guts of the machine, understanding how schedulers, memory managers, and file systems all interact in a delicate high-performance dance. You are forced to think about the system as a whole. When you study a course like Computer Networks, you learn about the fundamental protocols that run the internet, the trade-offs between TCP and UDP, and the challenges of routing and congestion control. You start to see the entire global network as one massive complex system. In a course on distributed computing, you grapple with the hardest problems in our field: consensus, data consistency, and fault tolerance. You learn why building reliable systems from unreliable parts is so incredibly difficult and so critically important. You move beyond thinking about a single computer to reasoning about a fleet of thousands of them working in concert. This is the intellectual training ground for building systems at the scale of Netflix or Amazon or Google. This is the secret that so many aspiring developers miss. They spend all their time on the surface level learning new libraries, new syntax, new tools. And that's important. But the real leverage, the real career acceleration, comes from going deeper. It comes from building a mental model of how all the pieces fit together. It's about understanding the first principles so you can reason about any new technology, any new challenge from a position of deep knowledge. When a hiring manager at a top tech company sees a resume with a master's in computer science from a top-tier institution like Georgia Tech, they don't just see a piece of paper. They see a signal, a powerful signal that this candidate has been through the fire, that they have done the hard work of moving beyond mere coding. It signals that this person has been trained not just to build components, but to understand, design, and reason about complex systems. It tells them this is a person who won't just close tickets, but who can be trusted to help architect the future of their company. And that right there, that is the entire game. That's the shift from being a temporary cog in a machine to becoming the person who designs the machine. It's the difference between a career of maintenance and a career of innovation. The single most valuable skill you can develop for a long-term, high-impact career in US tech isn't a specific programming language, it isn't a particular cloud platform, and it isn't the latest JavaScript framework that will be obsolete in 18 months. It's the ability to think in systems. It's the skill of reasoning from first principles. It's the deep, intuitive understanding of how a computer actually works, from the logic gate all the way up to the distributed network. This is the secret language that the best engineers, the staff and principal engineers, the architects, and the tech leads all speak. They can look at a complex problem and mentally decompose it into its fundamental parts. They don't just see a web application. They see a cascade of network requests, DNS lookups, load balancers, application servers, database queries, caching layers, and operating system calls. They understand the trade-offs at every single layer of that stack because they have a mental model of the entire system, not just the tiny piece they were assigned to work on. So how do you get it? This is the part where the video title finally pays off. The hint was, it's in this computing skills course. And I'm not talking about a quick tutorial or a weekend boot camp. I'm talking about a course or a curriculum that forces you to build a computer from the ground up. Not physically, but conceptually. The most famous example of this is a course called From NAND to Tetris. It's a profound educational journey that starts you with a single logic gate, the NAND gate, and has you build everything. You build other logic gates from NANDs. You build an arithmetic logic unit from those gates. You build a CPU from that. You build an assembler, a virtual machine, a compiler for a high-level language, and a basic operating system. By the end, you're writing a game like Tetris in a language you created, running on a computer you designed, built from the most primitive building block imaginable. This is not about learning to build a CPU. You will probably never do that in your day job. This is about forging a new way of thinking. It's an intellectual workout of the highest order. It forces you to confront abstraction at its core. It demystifies the entire field of computing. The magic disappears, replaced by a robust, crystal-clear understanding. When you've done this, a bug in a complex distributed system is no longer a terrifying, unknowable beast. It's just a problem at a certain layer of abstraction that you can reason about, diagnose, and fix because you understand what's happening underneath. You know how the message gets from point A to point B. You know how the data is stored. You know how the processor is executing the instructions. Now, NAND to Tetris is just one path. The Open Source Society University on GitHub has a complete, free, self-taught curriculum that mirrors a top-tier computer science degree. It guides you through the essential courses: computer architecture, operating systems, algorithms, networking, databases. These aren't just academic checkboxes. They are the pillars of computational thinking. This is the knowledge that separates the framework chasers from the system builders. So what is the one skill? The one skill is first principles thinking applied to computing systems. And the path to get it is by systematically working your way through the fundamental layers of abstraction that make up modern technology. This is your concrete action plan. Stop chasing the hot new framework for a season. Dedicate the next 6 to 12 months to a deep foundational journey. Here's step 1. Pick your curriculum. You can go with the structured NAND to Tetris course, which is available for free online. Or you can use the OSSU roadmap on GitHub to build your own curriculum from world-class free resources like MIT OpenCourseWare. The choice depends on whether you prefer a single, guided project or a broader survey of topics. Step 2. Carve out the time. This is non-negotiable. Treat it like a part-time job. 10 hours a week. That's an hour or two on weeknights and a longer session on the weekend. Cancel a Netflix subscription and invest that time and money, if needed, into your own mind. The return on investment is astronomical. We're not talking about a 10% stock market return. We're talking about a 10x return on your career trajectory and earning potential. Step 3. Don't do it alone. Find a community. There are Discord servers and forums for people going through these exact curriculums. When you get stuck on building your ALU or understanding virtual memory, and you will get stuck, having a community to ask questions and share insights with is the difference between quitting and succeeding. This also simulates a real-world engineering environment where collaboration is key. Step 4. Build in public. Start a blog. Post your progress on LinkedIn or Twitter. Explain what you're learning in your own words. Teaching is the ultimate form of learning. When you have to articulate how an operating system scheduler works, you solidify that knowledge in your own mind. And guess what? This creates a public record of your incredible journey. A hiring manager who sees a portfolio of shiny but shallow web apps might be impressed. But a hiring manager who sees a GitHub repository and a series of blog posts detailing how you built a compiler from scratch? That person sees an engineer. They see someone with grit, intellectual curiosity, and a deep understanding of the craft. You become a 1 in 1,000 candidate instantly. Now I can hear the objections. But I don't have a computer science degree, isn't it too late? Absolutely not. The internet is the great equalizer. All of this knowledge, which used to be locked away in expensive universities, is now available to anyone with a connection and the discipline to pursue it. In fact, coming from a non-traditional background and consciously choosing to master these fundamentals is a more powerful story than just sleepwalking through a 4-year degree. It shows intent, shows passion. But isn't this incredibly hard? Yes, it is. And that's the point. The value is in the difficulty. The process of struggling with these concepts is what rewires your brain. It's what forges the problem-solving skills. Anything truly valuable is difficult to obtain. If it were easy, everyone would do it and it would have no competitive advantage. The barrier to entry is your own willingness to embrace the struggle and do the hard work that others won't. This is the path. It's not a shortcut. It's a scenic route through the very heart of computer science, and it leads to a destination that most developers, who only ever learn the surface-level tools, will never reach. You stop being a consumer of technology and you become a creator of it. You gain the confidence to walk into any technical discussion, any system design interview, and contribute from a place of deep fundamental understanding. You'll be able to learn any new technology, any new language, any new framework with incredible speed, because you won't be memorizing syntax. You'll be mapping it to the fundamental concepts you already understand completely. This is the skill. This is the work. It's the single greatest investment you can make in your technical career. It's the foundation upon which everything else is built. So, close the tutorial on the latest JavaScript framework. Open a new tab, and start your journey from the beginning. Start from the first principle. Start from the NAND gate, and build your future.